Okay. Design plays an important role in the adoption and ultimately the success of mobile apps today. Designing mobile apps, however, is a long, complex process. Even a small feature has to go through multiple stages of design iteration to make it from a feature request to the hands of users. First, in the ideation stage, designers brainstorm possible ways to build a feature. In the process, they often look at examples of how similar features were implemented in other apps. A few of those ideas generated in the ideation stage will then make it to the prototyping stage. For mobile apps, this could be with paper prototypes or high-fidelity interactive digital prototypes. Then, one of the prototype ideas will make it into the implementation phase. Here, developers get involved, and they would help implement the feature in the actual app. Finally, once the feature has been sufficiently tested, it is released to actual end users. Now, throughout these different stages of design, designers would use multiple techniques to evaluate their designs. Prototypes are evaluated with techniques such as heuristic evaluation, user testing, or even performance testing. These same techniques can also be used for the implemented app. In addition, platforms such as usertesting.com that allows remote collection of usage videos with voiceover narration can also be used. Finally, once the app is released, creators can use, they can actually look at usage metrics to understand if the feature works as expected. And if sufficient number of users are available, they can also run A/B tests to test small design variations and further refine the feature. So this is what the app design process looks like today. In this work, we present a new way of testing mobile app designs. We call it Zero Integration Performance Testing, or ZIPT. ZIPT provides two unique advantages over current testing techniques. First, in the ideation stage, it allows designers, for the first time, to understand the performance characteristics of different examples that they are considering. This helps them make an informed decision about which examples they want to draw from. Second, in the later stages, ZIPT allows competitive benchmarking, by which I mean comparing the performance of your design to your competitors' designs. It does so with significantly lower cost and effort than existing techniques. ZIPT is able to provide these benefits by leveraging the large number of design ideas present in existing apps. ZIPT can be used on any publicly available Android app with zero development effort. It depends on paid crowd workers right now to collect interaction data and qualitative feedback. It then processes this information and surfaces relevant performance metrics for designers. Let me now show what using ZIPT looks like. So the first step is test creation. So to create a test, a designer will upload an app through ZIPT's web interface. They also describe a task that they want users to perform on this app, and also the number of users. For example, to test the store locator feature on the Macy's app, they could ask users to find the address of the closest store to a given zip code. Designers can also include feedback questions, such as qualitative questions related to rating the difficulty of the app or the task, or qualitative questions, such as asking about issues encountered in performing the task. Once the designer has submitted this information, ZIPT launches it on Amazon Mechanical Turk and lets crowd workers attempt the task. Crowd workers see a streamed version of the app through ZIPT's web interface, and the system records detailed interaction traces in the background as they attempt the task. These traces capture the different screens they visit and the interactions they perform on these screens. If you're interested in learning more about how the streaming and the capture works, I'll be talking more about it during my second talk today in the crowdsourcing session at 3:30. So once these traces are collected, ZIPT processes them and presents designers with different aggregate visualizations and metrics that they can use to understand the performance of the task that they just requested. So now actually let me show you the interface and show you what these visualizations look like. So here's the task. We asked, the designer here asked users to find the address of the closest Macy's store to the zip code given here. This is phrased as a question, so crowd workers will be expected to answer this at the end of the session. So once enough crowd workers have attempted this task, the designer can go and look at the different traces that are generated. So the first trace that we show here is from the designer, himself. So this is the golden tracer. This is how the designer thought users will attempt the task. So we can see here the different UIs that the designer went to, and there are 5 of them. And we see that the easiest way to do this task is to click on the hamburger icon on the top left and open the menu, click on Find a Store, and so on. And in 5 interactions, you can find the address of the nearest store. And we see here that on the last screen that the correct address should be 170 O'Farrell Street. We also see that it took the designer about 15 seconds to do this. Now, if I go back, all the other traces here are from the crowd workers. The designer can click on any of these and inspect how different crowd workers attempted this task. Well, slow internet, I guess. So in addition to interacting with these individual traces, designers have the option of looking at 3 aggregate views of this data. The first aggregate view shows them 3 metrics: the time taken by different workers to attempt this task, the number of interactions that they needed, and the completion rate that's self-reported. So we can see here that about 95% of the users were able to complete this task on Macy's. And for most workers, it took less than a minute. On this interface, the designers can also inspect outliers. For example, they can look at users who could not complete the task. Those are shown in red here. Or they can look at the users who took an unusually long time. For example, if we click on the red user here, we can go to that particular user's interaction trace. Okay, so I'll let this load. So we see here that this user performed 25 interactions, took more than 2 minutes, and still could not complete the task. So the designer can look at the different UI screens here and try to understand what happened. And what we'll see here is that instead of using the hamburger menu, the user here was trying to use the search bar. And unfortunately on Macy's, the search bar only searches over products. So you cannot really search for locations with the search bar. So by looking at these outliers, the designers can identify very quickly failure cases like these. Wow, it's really slow. Okay, there we are. Okay, so there are 2 other aggregate views that the designer can look at. So the one that I just showed was the aggregate metrics. They can also look at, in aggregate, all the user ratings. So they can look at, they can see, that, for example, that users reported that this app was actually easy for them to use. And they can also look at all the task answers, and we'll see that most of the users gave the correct answer to this task. Again, they can look at some of the outliers, such as the users who answered this incorrectly. And the final aggregate view that they have of the data is this flow visualization tool. Here, the different nodes show the different UIs and the different paths that users took throughout the app trying to attempt this task. And in dark gray here, we show the golden path that the designer had specified. What we see here is that 70% of the users take the first step that the designer expected, which is to click on the hamburger menu. So in this way, designers can get an understanding of how well this task performs by using data from crowd workers. We evaluated ZIPT in 2 ways. First, we performed a series of case studies on 15 popular Android apps. We collected between 15 to 50 interaction traces from crowd workers and paid about 30 cents for each trace. We also conducted interviews with 4 designers where we went over the case studies and also let them use ZIPT to explore the data for one of these case studies. I'll now talk about some of the findings from these case studies. First, I'll show 2 examples where we found usability issues in apps. Here, we asked users to pin images to a board in the Pinterest app. When we looked at one of the outliers who took a long time and still couldn't figure out the task, we found that she tried pinning images by clicking on the white icon that's at the lower right corner of these images. This unfortunately performs visual searches, a new feature in Pinterest. Perhaps the user expected to see a menu there, which is a common interaction pattern in Android. And the reason this works is that you can very clearly see what users did in the app. One of our participants, one of our designers, he said, it seems like there's very little that you lose compared to having an over-the-shoulder video camera. For this example here, we asked users to add a cookie to their daily log in a personal food app. And we found that a lot of users dropped off on this particular screen and encountered an error. This happened because when entering the number of cookies they ate, they had to enter a unit on the right, which they forgot to do. When we showed this data to our designers and we let them explore this data for 10 minutes, they identified multiple usability issues on the screen. For example, one of them said that the screen clearly does not clearly communicate that something else was needed. Designers also generated multiple solutions to how we could fix these usability problems. This included pre-selecting one of the options, restructuring the data entry process, changing the component, and modifying the layout. In our surveys, designers, after this experience, believed that they had found at least one usability issue in the app. So this is how ZIPT can be useful for finding usability issues. ZIPT can also be used for for comparative evaluations. Here, we compare the store locator feature in Macy's versus Best Buy. In Macy's, there's one way to find the location of a store. In Best Buy, there are 2 ways, and both of them require fewer interaction than Macy's. What we found out, though, was that people reported that Best Buy had a lower task, Best Buy was harder and had a lower task completion rate. When examining the traces, we found one possible cause of confusion. Users did not really understand the scope of Best Buy's search bar, which changes depending on the selected tab. The user shown here, for example, tried to search for stores on the Home tab, which searches over products. In this example, we asked users to create a new playlist and add 2 songs to it on 2 popular apps, YouTube Music and Spotify. We found that YouTube Music had a lower completion rate, and that is because users could not create an empty playlist first and then add songs. Spotify allowed that, as well as the other way around, where you can go to a song and then try to add it to a playlist and say that it's going to be a new one. It seemed like users wanted this affordance to be able to create an empty playlist first, and this was something that a lot of users were confused by in YouTube Music. One user even tried to use the app's help functionality to learn how to create playlists. During our interviews, one of the designers mentioned that this is something that he has seen in other products before. He said, people like to think of containers as things. You want to be able to have an empty thing first to put things in. It's how we think of stuff. So hopefully, these examples convince you that ZIPT can be useful for finding usability issues, as well as for performing comparative evaluation between apps. So in terms of benefits, there are 3 big benefits of ZIPT that came up during our discussions. First, ZIPT requires significantly lower cost and effort to run comparative tests compared to existing techniques. It is 100x cheaper than using something like usertesting.com. Also, since we collect structured data, you get aggregation for free. The implication of lower cost and effort is that now it's possible to do comparative testing at scale. The second unique benefit of ZIPT is that it collects both quantitative and qualitative data. The quantitative data helps understand what works or does not work. The qualitative data helps understand why. The final benefit that I'll talk about is that ZIP allows learning from the designs of others. Perhaps the designers at YouTube Music knew that users like creating empty playlists first in their music apps. Now with ZIPT, everybody else can learn that using their app. Used in this way, ZIPT encourages testing earlier in the design cycle. Going forward, we hope to create a unified design exploration platform for mobile apps that combines design search with a ZIP-like system to run targeted, inexpensive tests. Imagine what would be possible if we were able to democratize the design knowledge that remains embedded in individual teams today and make it available for everyone to learn from. If you're interested in hearing more about the design search part of this, I'll talk about it again in my second talk, which is at 3:30. Also, if you'd like to use ZIPT for your own work, we have a sign-up form that you can find at interactionmining.org/ZIPT. Thank you.
And your system seemed to afford having multiple designer-suggested ways of getting to a goal.
Right.
Did you see any time where a designer saw people coming up with another way of generating, or is it like new things that they liked better?
So actually, in our studies, we did not let the designers create the task themselves. So we did the case studies ourselves, and so we found some of those instances. For example, the Spotify and YouTube Music case. Like, we did not realize that Spotify had two ways of doing this, and then we realized when people were confused on YouTube Music and were trying to do it that way, we realized that like Spotify has two ways, and half of the people are doing it this way, and others are doing it that way. So that's an example of us discovering that the app supports doing this task in multiple ways.
Gonzalo Ramos, Microsoft Research. This is amazing. As someone, I've been involved in creating apps, and I know how helpful this can be. I'm super excited about future directions. You mentioned something about leveraging the science for future creation. Do you see what you did applicable to flows that include not already the app existing, but I have a sketch file, right? Or Adobe, the experience design project that already has a little bit of, it's like an app. It's not really an app, but it is an app.
Right.
If you see that this can be applied to that sort of material to do analysis and a very tight design loop.
Right. So yeah, that's an interesting question, because if I go back to the slide where I showed the design process, right? So we built a tool in a way that we are hitting the ideation stage, we're hitting the implementation and release stage, because we're working with apps here. And what you were talking about, I think, is in the prototyping stage, you have these digital prototypes, and you want to be able to use something like this there. I think right now, the current tool is like, we have built it for Android, so not right now. But I think the overall approach that we take for capturing data, and we capture three kinds of data. So we take screenshots, we capture Android view hierarchies, which is like a structured representation of the UI, and we capture all the user interactions. So for some of these prototyping tools, if you're able to capture those three kinds of data, then you can use a similar way as us to kind of aggregate the data and show it in this manner to designers and run tests on them.
Hey, Ariel Weingart, Design Lab at UCSD. Love this, and I was wondering, if you checked into I think it seems all above the belt, the legality of using other people's websites and paying people to use those websites to learn things about their designs. And so did you run into anything interesting there, or do you expect that someone may tap you on the shoulder and just be like, hey, can you at least funnel back all the learnings to us, please?
Right, that's an interesting question. Yeah, we haven't run into that yet. I know that in practice, this is something that people do at a smaller scale, right? Competitive testing is something people do, but you do it in person. You would download the apps to a phone, you would bring users to the lab, and you would do it at that scale. We are just making it easier to do it at a larger scale. So in practice, that happens. I don't know the legal implications of studying other people's apps. I don't think, I am I'm an expert on that, and I don't think I should comment on that. Yeah, so
No,
not
no.
really. We haven't run into that, but we'll see what the future brings.
Cool, thanks.